Hello. Welcome to the session on T-joint on MS pipe of outer diameter 50 mm and wall thickness of 3 mm in flat position 1F using gas tungsten arc welding GTAW. Let us look at the objectives of this session. At the end of this session, you will be able to weld a fillet T-joint on a MS pipe of 50 mm outer diameter and 3 mm wall thickness in the flat 1F position using TIG welding process. Understand diverse welding techniques for MS pipe T-joints, considering factors like pipe thickness, filler metal, and skill level. Highlight the importance of weld quality, factors influencing it, and practical methods to mitigate them and ensure reliable joints. The tools and materials required to weld T-joint on MS pipe are TIG welding machine, tungsten electrode, shielding gas argon, MS pipe, hacksaw, metal files, bench vise, wire brush, chipping hammer, profile machine, hand grinder. Now, let's prepare the MS pipe of outer diameter 50 mm and 3 mm wall thickness. First, clean the MS pipe with a wire brush to remove any dirt or debris. Cut the pipe to 100 mm and 75 mm lengths. Make sure that the edges of the pipes are square and perpendicular to each other. If the ends of the pipe are not square or perpendicular, the weld may be weak or may not hold together properly. Use a file or a grinder to make it square or perpendicular. The cutting of branch components in mild steel is a challenging task. For T-joint, branch pipe and main pipe, both to be cut on the pipe development profile, simple cut is not possible for T-joint. The branch can be produced by marking the outline using a template figure. First, a template figure of the desired branch should be prepared. This can be done by drawing the figure on a piece of paper or cardboard. The template figure should be the same size as the branch that you want to cut. Once the template figure is prepared, it should be placed on the mild steel pipe where the branch is to be cut. The outline of the template figure should then be marked on the pipe using a scriber or pointed chalk. After the outline of the branch has been marked, the center of the branch should be punched. This can be done using a center punch or a nail. The center punch will make a small indentation in the pipe, which will help to prevent the cutting torch from straying from the marked outline. The branch can then be cut to the marked outline using manually operated oxy-fuel gas cutting equipment. The cutting torch should be held at a 45-degree angle to the pipe and the cutting should be done slowly and carefully. Branch holes can be cut using a variety of methods depending on the equipment available. Two of the most common methods are oxy-fuel gas profiling machines, manual oxy-fuel gas cutting. Oxy-fuel gas profiling machines are a specialized type of cutting machine that can be used to cut branch holes in pipes. These machines use a combination of oxygen and acetylene gases to create a high-temperature flame that can cut through metal. Manual oxy-fuel gas cutting is a more basic method of cutting branch holes in pipes. This method uses a handheld torch to create a high-temperature flame that can cut through metal. The flame from the oxy-fuel gas cutting torch can reach temperature of up to 6,000 degrees Fahrenheit. This is hot enough to melt and vaporize the metal, allowing the torch to cut through it. After cutting to length, remove any burrs on the inside of the pipe by filing. Clean the surface of the pipe if any oxide is found. Now, let's weld the branch pipe with the main pipe. Ensure to wear proper personal protective equipment such as helmet, gloves, and long sleeves before starting the welding process. Now, set up the welding machine. The welding current should be set to a low setting, such as 60 to 90 ampere. The welding voltage should be set to a high setting. Once the welding machine setup is over, set and align the branch pipe with the main pipe at an angle of 90 degrees. Make sure to keep the root gap as 2 mm to control distortion and to obtain penetration. Ensure proper melting of tacks for good penetration and surface appearance. On T-joint, use a sequence welding technique. The preferable sequence for a T-joint is as shown. Whenever possible, do all the welding in a downhand position. Manipulation of the torch and filler wire during welding the T-joint should be correctly followed. Once the welding is finished, use a chipping hammer to remove any slag from the weld. Inspect the weld for any defects such as porosity, cracks, or incomplete fusion. If you find any defects, you may need to weld the joint again. Finally, clean the weld using a wire brush to remove impurities and make it look more polished. Let's recap the key points discussed. Clean the MS pipes with a wire brush to remove any dirt or debris. Set up the welding machine. Align the branch pipe with the main pipe at an angle of 90 degrees. Once the welding process is over, inspect the weld for defects. This brings us to the end of the session. Hope you have gained a good understanding about T-joint on MS pipe of 50 mm outer diameter and 3 mm wall thickness in flat position 1F using gas tungsten arc welding GTAW. See you in the next session.